Hello, I'm Paul Chin. I welcome you to this course called Fundamentals of Building a Remote Access Tool in C#. If you want to learn C# programming and networking basics in a fun and exciting way, then this is a course for you. As you all know, remote access tools are often misused to become remote access Trojans. So in this course, you will learn how to create such a remote access Trojan. The learning methodology employed in this course is to build programs that simulate Windows remote access Trojans. The best way to understand how remote access Trojans work is to write one. This will make you a better security professional, whether as a malware analyst, reverse engineer, or ethical hacker. What you will learn in this course. In this course, you will cover networking essentials, socket programming, client-server socket communications, multitasking and threads programming, creating port binding shells, writing reverse connection Trojans, firewall penetration techniques, creating invisible and hidden Trojans, command and control methods, remote command execution methods, creating unlimited commands in a server Trojan, building a Trojan that can auto-respond itself, and more. Who this course is for? This is a beginner's course for students who like to get started on the career path to become malware analysts or penetration testers. It is also suitable for reverse engineering and malware analyst students, and also for programmers who want to know how malware is created. It is also suitable for penetration testers, ethical hackers, and red teamers, or for anybody wishing to learn C# programming in a fun and exciting way. Prerequisites. For this course, you will need to have a Microsoft Windows PC. Some basic programming and networking knowledge will be helpful, but not strictly mandatory. It is assumed that you have no basics whatsoever, and I will teach you everything from scratch. A little bit about my background. I'm a retired college lecturer, and I have been teaching computer science and IT for more than 20 years. I welcome you to this course, and I'll see you inside. Hello and welcome. In this video, I'm going to show you how to install Visual Studio Community 2019. Just head over to this website here, and you can get this link from the resource file which I provide for you as well. So download this, click the link here, and you should have a file, something like this. After downloading, just double click on this to begin the process of installing, and soon you will get a dialog something like this asking you which of the framework and modules that you want. So this is the one that we are going for, .NET Desktop Development. So make sure you just check this one and leave all the rest unchecked. We don't need any of the others. We only need this one. So after you check on this, you will see some of the default optional modules here, and you can uncheck which one you do not want. For example, we don't need Blend, Entity Framework, and ML.NET. All that we don't need, so we can uncheck those, and you will find that our installation space has reduced to 5.84. So all the rest we can just leave it as it is, and we also don't need live share, so we can remove that to save some more space. And then over here you will see the option here, install while downloading, so we can leave it as it is, the default, and make sure all the rest are correct, then click on install. So notice that I'm installing Visual Studio Community 2019 at the time of recording. So just hit on install, and it has started to download the necessary files. And if you don't want it to start after installation, you can uncheck this. So I'm going to uncheck this option here. I don't want it to start after installation, so I'll leave it unchecked and let it continue to install. I'm going to pause the video and come back once it's done. After some time, you will find the installation is complete. It could have taken half an hour or maybe a few hours depending on your internet connection speed. And this is what you will see when it has completed. And there is a launch button here which you can click to launch it, or you could head over to the bottom left corner and then search for Visual Studio. Just click search Visual and you will see, just search for Visual and you will see the Visual Studio 2019 here, and you can launch it from here. So this is how you install Visual Studio Installer. You can now click on this to close it. So I will see you in the next video. Thank you for watching. Hello and welcome back. There is another tool which we will be using. It is called Telnet. So to use Telnet, you need to open a command prompt, a command line interface. So you can click on the bottom left corner here, type CMD for command prompt, and then click on the result that you see to launch the command prompt. Telnet is used from the command prompt. So to use it, you're supposed to type Telnet and hit enter. But you will see that there is an error which says that Telnet is not recognized as an internal or external command. So we need to enable this feature in Windows 10. So to enable this feature, just go to the bottom left corner, and then in here search for turn Windows features on or off. So when you type the search string turn Windows, it will show you a result, turn window features on and off. So just click on this now, and then wait for it to populate the list of Windows features, and then scroll down and look for Telnet, which is this one, Telnet. So click on Telnet client and then click on OK. After that, it's going to search for the required files, and then it will apply the changes, and it will give a message saying that Windows completed the requested changes. Then just click on close. So now you can try to run Telnet again, and you can see that it has opened the Telnet prompt. So this is the Telnet program that is used for testing network connectivity, which we'll be using in this course. So you can type help here. We can see all the options for the Telnet command. So we'll be using some of these options later, and I will also show you how to use Telnet later on in the course. So you can quit this now by typing Q and hitting enter. So that's all for this lesson. Thank you for watching. Hello and welcome back. In this lesson, we are going to learn how to write your first Hello World network program. So before we do that, first create a folder called Red Projects in your C drive, as I have done here. Next, let's open Visual Studio 2019 by going to the bottom left corner, clicking on the start icon, and then search for Visual Studio, and you will see Visual Studio 2019. So just click on it to launch Visual Studio. Next, click on Create New Project. So there will be a list of templates here. We are going to limit the list here to C# Windows Desktop. So click on this here, select C#, and here select Windows, and here select Desktop. Then you narrow down the list. Now from this list here, just scroll and look for Windows Forms App .NET Framework, this one. So just click on this and then click on next. In the location field, click on the three dots here and choose the new C folder, the new Red Projects folder in your C drive. So go to the Red Projects folder, click select folder. Before that, inside here, create a new folder called 01-hello. Then click on the new folder that you have created and click on the button select folder. So now you should have this new folder selected. All our projects will be organized in a very organized and neat way by putting numbers in front, so that when we look for our folders, it will be neatly arranged in chronological order. After that, let's give a name to the project by changing the name here to hello. And then the default is .NET Framework 4.7.2. If it's different for yours, just accept the default and then click on create. So this is the user interface or the IDE, Integrated Development Environment, for Visual Studio 2019 for C# projects. In the center here, you will see your design for the user interface. On the top right is the high-level view of all the folders inside this project. And the bottom right are the properties for each of these objects here. So if you click on Form 1 object, you'll be able to see the properties for Form 1 on the bottom right corner. And at the bottom window here will be the output to show you what is happening as you build and compile this program. And if there are any errors, it will also show up here in the error list as well as the output. Now the default build is debug. Later we will change to release, but for testing purposes we can leave it at debug. And the default CPU is any CPU, so we just leave it as it is, no need to change anything. So right now you can click on this button to build your program and run it at the same time. So let's do that now. Click on Start and it will build. As you can see in the output window, it says build started, and after a while it shows you your application which is running. It is called Form 1. And to stop this application, you can click this stop button here, or simply close this application close button. And so it's closed now. So this is how you can build a simple application using Visual Studio 2019. The first thing we want to learn is how do we hide this. That means when we run this program, we don't want the windows to show. Now when you are writing a ret, you do not want to alert the user that there is something going on. That's why we need to hide it. There are a few ways to hide it, but one of the simplest ways to hide it is to change the form's opacity. To change the form's opacity, first click on this Form 1 and then in the bottom right, look for opacity. You can just scroll until you see opacity here. Currently the opacity is 100%, meaning that this form will be fully visible when it runs, as you have seen. If you want to make it invisible, you can change this to 0% opacity. Now if you start the program and build it again, you will see that it is not showing anywhere. Yes? So this is what I mean by setting opacity to 0. But you can confirm that it is still running by right-clicking at the bottom bar here and click on Task Manager. If you click Task Manager, you will be able to see that Hello is running over here. Hello. And it is a 32-bit program. So now if we were to stop this program, we can click this button here to stop the program. And if you go back to your Task Manager, you will see that the Hello is no longer there. So this is how you can make your application invisible using the opacity. So in the next video, in the next lesson, I will show you another way to make it invisible. So thank you for watching this video. Have fun. In the previous video, I've shown you how to make your application invisible by changing the opacity of your form, setting it to 0%. In this lesson, I'll show you another way to make your program invisible by writing code. Okay, so what we're going to do now is to insert an event handler. So how do we insert an event handler? To insert an event handler, click on the lightning icon here. If you hover your mouse over it, you will see the pop-up label called events. So just click on it, and then below that you will see a list of all the events that can be captured, that you can capture. So these are all the events that can happen for this form. For example, click, double click, mouse capture, change, mouse click, mouse double click, resize, begin, resize, and these are all the actions that people can perform on your form. So these actions that people can perform are also known as events, and we can capture these events and do whatever we want with the events. Now, one of the events which is useful that we can exploit to hide the form is called form shown event. So look for the shown event under S, S-H-O-W-N, shown. So in order to do something with this event, we have to insert an event handler. So to do that, just double click on this shown event here, double click on it, and it will generate the code for it over here. So this is the source code for in C#. You will have the top here, you will see using, system, using, and so on. So there are many using statements. The using statement means that the C# program is importing a library. And why does it import library? So that you can use the functions that those library provides. So in this case here, we want to use the form shown event, so that's why it automatically imports the necessary libraries for you. So you need not have to worry about this here, just leave it as it is. And then here, namespace hello. The namespace here is to give a name for this app, which is called hello. And then inside that you will see a class. So every C# program has got a class. So when you're writing C#, it's just like Java. Everything is in a class. So classes are the templates where you can build your objects or your programs. So inside here you will see a constructor. A constructor is takes the name of the class, form1. So whenever your program runs, it will call the constructor and do whatever is necessary to initialize your application. And after it's done that, you can now put whatever code you want inside each of these functions. So in this function, or in C# we call it methods. For this particular example is form1 shown. So we have already generated this by double clicking the events icon just now. So now we can put our code here. So whenever the form is shown, that means when it appears on the screen, you want to do something. So what do you want to do? We want to hide it. We want to hide the form. So the first thing we write here is this.hide. This.hide. Like this. So this here refers to this class or this application. When the form loads and is being shown, it will trigger a form shown event, and that function event is handled by this event handler called form1 shown. So let's run it now and see what happens. And you can see it is totally invisible. It doesn't even appear in the status bar. See that? It's totally invisible. If you look at the task manager, and then you can kill it by clicking on this stop debugging, and the program will start running. If you did not have this program, if you did not capture the event handler to run this function, then your application will be visible to in the status bar. So let's comment this out. So how do we comment out? We comment it out by putting 2/ in front of the statement. So each of these is a statement. In programming, we have statements, and each statement is like a sentence giving instructions, and every statement ends with a semicolon. And here, if we don't want a particular statement to execute, we can either delete it by removing, or we can convert it into a comment by putting 2/ in front. So this is how you insert comments. You can do it by putting 2/. So you can say, let's say I want to insert a comment here, put 2/ and say my first C# program. C# program. So this is to explain your code. Comments are used liberally. Put it anywhere you want to make your code easier to understand, to read and to understand. And then another use of comments is to disable a particular instruction. So this is the ingenious way to disable an instruction, a statement, to disable a statement without deleting it. So we can put 2/ and that will disable this statement. So now if we run again, notice my status bar at the bottom. When I run it, you can see that there is an icon here showing that something is running. Let us stop this program, and this time we enable this statement by removing the comment and run again. Okay, so it is running, but this time you won't see it in the status bar. It is totally hidden. So that's all for this video. Have fun with the code. I'll see you in the next one. Thank you for watching. Hello and welcome to a lesson on networking. And for those who are beginners to networking, this is an introduction. Core essentials of networking. This is a diagram of a simple network program. A simple network program consists of two parts, a server and a client. The server program must be started first and waits or listens for the client program to connect. On the left is the server, on the right is the client. And the server must be started first and waits for the client to connect. Reverse connection RATs, remote access tools. It is also possible to have the server connect to the client, as in the case of a reverse connection RATs. Reverse RATs are used to bypass firewall or router limitations. Normally, those computers that are sitting behind a router or a firewall cannot be reached from outside because the firewall will block the connection. So in this case, if you are planning to target a particular machine inside, after you have managed to infiltrate through phishing attack, for example, to install a RAT in the server, then the RAT will initiate the connection. For example, if it uses port 80, the firewall usually doesn't block port 80. Port 53 also usually doesn't block because port 53 is DNS. So this is an example of where you might use reverse connection RATs in order to penetrate the firewall. Location of server and client. Usually the server program resides on one computer whilst the client resides on another. However, both can be on the same local area network, LAN, or on the internet. Also, both can reside on the same computer for testing purposes. Remotely executing commands. After the server and client has established a connection, the client will send a command to the server. Upon receiving the command, the server will execute it. Example commands are, for example, to display message hello world, beep, shut down, reboot, activate hardware, create files, delete files, run programs, and so on. In short, any command that could be ordinarily executed by a user sitting in front of a computer. IP addresses versus port numbers. IP addresses, also known as Internet Protocol addresses, are the address of the house. Port numbers are the people who live in the house. IP addresses is the address of the computer. Port numbers are the server processes running in the computer. There can be more than one server process running on a single computer. Therefore, for each IP address, there can be more than one port number. For example, on this machine here, it has an IP address of 192.168.1.2, but it can have multiple port numbers because there can be more than one services running on the computer. Each service uses a port number. Port number 21, for example, 25 and 80. 21 is the FTP server, 25 is the SMTP server, and the port 80 is the web server. Local area network versus internet. IP addresses, for example, 192.168.x.1 to 192.168.x.254 are reserved for LAN use. The X here refers to numbers from 1 to 255. There can be other range of internal IP addresses as well. This is only one example in the class C range. There can be class 1, class A, class B, and class C, and so on. There's a special IP address known as 127.0.0.1, which is also known as the loopback address. It refers to the local machine, the local computer itself. For the internet, the IP addresses are assigned by a Internet Service Provider, ISP, when a user connects to the internet with a modem. Therefore, a computer can have multiple IP addresses. Each IP address will be bound to a network interface. The network interface is your network adapter. Port numbers, also known as sockets. Port numbers can range from 1 to 65,536, but the port numbers 1 to 1024 are reserved for special use. For example, 21 is File Transfer Protocol (FTP), 23 is Telnet Server, 25 is SMTP for email, 80 is HTTP, also known as web server, and so on. Any number above 1024 we can use for writing network programs. But before you actually use a port number above 1024, always check first to make sure that it is not already in use. Checking IP and port numbers. So this is how you can check. To see the IP addresses and port numbers on your machine, first open the command prompt and issue the following command: netstat space -TAN. TAN here refers to the options TCP protocol. A means all, N means in numerical form. That means in IP address. Do not try to resolve it to names. You should see something like this. So here is the output of a command prompt where I've already typed the command netstat -TAN. In the first column is your protocol. There are two kinds of protocol which I will explain later, TCP or UDP. And then the second column will be your local address. 0 means any IP address. That means it is bound to the local machine. Whenever any incoming connection comes to this machine, it will be bound to the local machine because of this 0000. Then separated by a colon is your port numbers. So these port numbers are unique for each service that are running locally. These are all services. And then here are the foreign address. That means computers which are outside your computer, outside your network, or it could also be in the same local network but on a different machine trying to connect to your computer. But at the moment, if you see zeros, that means there are no connections to these services. And then on the fourth column will be the state. It can be either in listening or established, and so on. And the last one, you can simply ignore it. And you will see here this line, this row here, there is a connection coming from your machine going out to the internet, to the IP address shown here at this port number 443. Differences between TCP versus UDP. TCP stands for Transmission Control Protocol. It is a protocol used to establish connections with other computers on the internet or even in a local area network. When a client wants to talk to a server, it will follow the protocol of TCP to try to establish a connection first. If a connection is established successfully, then a client and server can talk. So this is an example of an output where you can see the first column TCP and below that you can see UDP. I'll be explaining UDP next. UDP, on the other hand, stands for User Datagram Protocol. It's another protocol used for communication on the internet or even in a local area network. But unlike TCP, the client need not establish a connection with the server first. The client just sends the message, irrespective of whether the server is up or listening. However, if the server was not listening, then the message will be lost. So what is the difference between the two? What's the advantage? When do we use TCP or UDP? TCP is used when you want to have a reliable communication. For example, if you are transferring a large file, you want to make sure that the file is transferred bit by bit and arrives safely without missing packets. And then you will use TCP. But TCP is slightly slower than UDP. UDP, on the other hand, is suitable for very short messages like DNS queries and so on. So when you're trying to query for the IP address of a host name, then you will use UDP over DNS service. TCP/IP protocol. Both TCP and UDP belongs to the TCP/IP protocol. Note that the IP address is followed by the port number and separated by a colon. Take a look at this screenshot here. In this row here circled in red, you will see that this machine is running a service called the NetBIOS service. NetBIOS is used for Windows networking. It is listening on port 139. Any number less than 1024 is usually a server that is running. And then in this column here, there is no connection to it yet, so you see all zeros. Note that the IP address is separated from the port number by a colon here. So in this case here, 192.168.0.114 is the IP address, and port 139 is the NetBIOS port used for Windows networking. The need for client port numbers. Note that clients also need port numbers and IP addresses. Consider the connection outlined in red here. You will see here that your machine is using port 54116 to connect to another remote IP address in the internet with this address and having the port number 443, which is also known as an SSL port, Secure Socket Layer. This port number 54116 is dynamically assigned by operating system. But port 443 is a well-known port number for SSL. It's a server running SSL. So any two machines which want to communicate must have two things: IP address to identify the machine and port number to identify the process which is going to communicate. The local computer with IP address is 192.168.0.114 is using port 54116 to connect to port 443 at the remote IP 20.198.162.76. IP addresses versus port numbers. This diagram here shows two different computers. On the left, we have a computer with the IP address 192.168.0.114, and on the right we have another computer 20.198.162.76. This machine is typically a server because you can see the port numbers are well-known port numbers: 21 for FTP service, 25 for SMTP or email, 80 is for web server, and 443 is for secure socket layer, SSL, which is also a web service but running encrypted over the internet. And on the left is your machine, and typically your machine is also known as a client machine because it is trying to connect to the service on the server. That's why it is known as a client. And normally the client will have a big number above 1024. As you can see here, there are many processors with big port numbers, and each of them are trying to reach somewhere on the internet to another server. So in this case here, the port number for this machine is 54116, and it's trying to reach out to this machine at this IP address running service at port 443. So you can view this as a house which has got an address, IP address, and within the house we have multiple occupants. Each occupant is different from the other. And on the right is also another building which has its own address, and within that building you have another few occupants, each providing different services. So that is the reason why we need to have port numbers. IP address alone is not sufficient. IP address can only identify the machine, but you also need port numbers to identify the service which is running on the machine. Which service do you want to connect to? So that's all for this background on networking. Thank you for watching. Hello and welcome. In this lesson, we are going to learn to write your first network program. So let's use the same project we did earlier. Open your Visual Studio 2019 and then just click on the previous project, which should be in this list here. If you don't see here, you can also open by using this button here, open a project or solution. Click on this, and then you can navigate to the folder where your project was stored, which is in the C drive in the red folder, red projects folder, hello, and then click on hello.sln. SLN stands for solution. So just click on that and open, and it will load the project which you did earlier. So we are now going to write some code to make this into a network server. That means this program will listen for a connection, and then once it has connected to a client, we are going to use the Telnet client which you installed earlier, and the Telnet client will then send a message to this server, and the server will then receive that message and do something. It will receive the message and show a message box with some hello world string. To do that, we must first create a listener. So go to this function here, or this method here, and then below the height here, open a new line and then type TCP listener. TCP listener. And you will see that there is a red underline here, which means to say it doesn't know where this object comes from, where this class comes from. So it asks you to click here, show potential fixes. So you can click on this and see the help that it will provide for you. So these are some locations where TCP listener can be found. So the one we need is this one, using system net sockets. So click on this, and then it will import it over here automatically for you, system.net sockets. So over here now you can put a comment to remind yourself that it is for listeners and sockets. So now that it has inserted this library for you, you can now make use of TCP listener. Now we can create an object out of the class. So to create the object, we type in the name, just any name you like. We shall call it TCP listener. TCP listener. And then we have to call the constructor by using the new keyword, and then type TCP listener here again, the constructor. And here is where we need to specify the parameters for our constructor. So as I mentioned before, a constructor is the first method that is called by a class. So every class will have a constructor. In this case here, the form1 constructor is called form1. And then for TCP listener, the constructor for TCP listener is called TCP listener. However, you need to use this special word called new in order to use the constructor. So we want to construct an object out of this class and then return it to the variable we declared here. So this is the meaning of all this here. So what are the parameters that you can pass to the constructor? There are three. You can either pass just a number, or the second one, you can click on this button. You can pass the endpoint, or the third one, you can pass the IP address as well as the port number. So we are going to use the third one. So this is the one we want. So we just follow the syntax here. We type system.net, and as you type, you can see the IntelliSense popping up to show you some helpful hints. And then here you supply IP address, press tab to auto-complete it, and then here what IP address you want to use, you can put dot here, and then here it pops up some of the possible matches. Then you select the first one, any. That means any IP address you want to use. You want to use all the IP address that are available on this machine. Then the second parameter is a port number. As you press the comma, it will open up the parameter list for you again. So the port number, you can choose any port number, but I will advise you to use those which are above 1024, because anything less than 1024 is reserved for special use for the well-known ports which I've explained earlier. So we can use, say, 4444, which should be quite available because no services are making use of port 4444. But you can always confirm it by opening the command prompt and typing netstat-tan to confirm it. So you can type this now. If you want to confirm that port 4444 is available, type cmd and then click on the command prompt here and then type netstat space -tan, hit enter, and then now you can scroll and make sure that port 444 is not being used. You can see port 135, 443, 445 and so on are already being used, and you can keep scrolling down to see all the ports that are being used over here, and you can confirm that none of the ports are 4444, so it's quite safe to use 4444. So we can come back here now and just confirm our 4444, and then to end the statement, we put a semicolon at the back. So this is your first line in your networking program. You are going to create a TCP listener. So you use a TCP listener class, declare an object out of the class, and give a name for the object. So we call it TCP listener with a lowercase t, and then here we call the constructor for the class in order to create the object and to give it the parameters that we want the object to have. So here we supply the first parameter as any IP address. That means bind to any IP address which is available on this machine. So if this machine has got 2 or more network adapters, then it will bind to all the network adapters. And then here, second parameter will be your port that you want to use for this network program. So if you run this program, it will open a port 4444 and listen for connections, but you have to start it. So the next line we are going to start it. So we call TCP listener, and then you can press tab for completion and then hit and then press dot and see what are the possible methods that exist for this object. And you can see here a list of possible objects, a list of possible methods methods are functions. In C#, we say methods, but they are actually functions. They mean the same thing. So what are the methods available? So the one that we are interested here is start. This is the one, start. So you can just double click that, start, and then put the function brackets and close it with a semicolon. So now the listener will start. Alright, so but that is not sufficient. It has to create a socket. A socket is the port. So in order to create a socket, you must use the socket class. Socket class with a capital S, and then give a name for your object, for this socket object. So you can call it socket for client. Always give something meaningful so that it makes it easier to read and understand your code. And then here we are going to use the TCP listener to open the socket. So the TCP listener is already listening. So once the TCP listener is listening, you can call the TCP listener's object called accept socket. So just type a dot here and you will see a drop down list of all the possible methods for TCP listener, and the one that we need is the first one, accept socket. So we can just click on that and then finish it up with our function brackets and semicolon at the back. And so now we have a socket. That means we have the IP address bound to this machine, and we have a socket listening port 4444. So the next thing we want to do is to create a pipe. A pipe is called a network stream. So the pipe will be the pipe through which all the data will flow through the socket. So to create a pipe, we use the network stream class. Network stream. As you type, you can see that the IntelliSense has popped up a suggestion for you. Very helpful. So all you need to do is just press a tab and it will auto-complete the name for you. So now we want to create a network stream object. We just give a nice name which is easy to understand. So we just type network stream as a name with a lowercase n. And then here again we call the constructor for network stream. So we have to use the new keyword in the same way that we did for TCP listener when we wanted to call the constructor for TCP listener. So here we are going to call the constructor for network stream. So just type network stream there, and then you need to pass a parameter for it. So when you open the brackets, it pops up 4 possible parameter lists. So when you put your brackets here, it will pop up the parameter list. There are 4 possible parameter lists. The first one accepts just one socket. Second one accepts socket and other options. And then third one accepts these parameters. And then there's a fourth one as well. The one that we want is the first one. So just hit the up arrow and the first one is what we want. So all we need to do is provide a socket for it. So the socket that we created is socket for client. So we just have to type it in here. Socket for client. That's it. And then we end it with the semicolon. So now we have created a network stream that will be used as a pipe for the port for the data to flow through. So now that we have the network stream ready, we need to have something that can read this data. So for reading the data that is coming through the stream, we need a stream reader. So we type stream reader. However, you will find that stream reader is not known because we have not imported the library for stream reader. So what is a library for stream reader? Just hover your mouse over here, and here it says show potential fixes. So just click on this, and then here it helpfully suggests using system IO. So just click on the first one, and then it will import your system IO. System.io is the input-output libraries, which contains stream reader as one of its classes. So now stream reader has been resolved. We can create an object out of this class by giving a useful easy to understand name. We just call it stream reader, and then we have to call the constructor for stream reader. Note that this symbol here is not equals but assignment. That means whatever is on the right is assigned to whatever is on the left. In programming, if you wanted to use a mathematical equality operator, you have to put two equal sign like this. If you put one equal sign, it does not mean you are comparing. It means that you are assigning whatever is on the right to whatever is on the left. It is equivalent to this. This is what you are doing. Whatever is on the right is assigned to whatever is on the left. So don't make the mistake of thinking that this is equality. This is assignment. So you create you call the constructor for stream reader, and then you call the constructor using the new keyword, and then the name of the stream reader constructor, and inside it you put your parameter. So these are the possible parameters. You have 11 possible parameters, but the one that we need is the first one. Is the network stream. So we just have to type in the network stream that we created up here inside the parameter. That's it, and then end it with the semicolon. So now you have a stream reader that can read your stream, which is created for the socket. So the next thing you want to do is to read the first line. So to read the first line, we need to create an object called string, and string is able to store whatever data that is being sent, characters that are sent over the network. So we are going to assign to this new string whatever comes from the stream reader. So we can use the stream reader to read a line. So you put stream reader object, then you put a dot here, and then here we show you what are the possible methods that exist for stream reader. So the one that we want is stream reader dot read line. So you can scroll down, you can see there's one here. Alright, so read line reads a line of characters from the current stream. So just double click on this and then put the function brackets and end it with the semicolon. So read line means to read until the person enters the new line character. The new line character is the enter key of the keyboard. When somebody types a sentence and he wants to finish the sentence in programming, when you want to finish a sentence, you will press the enter key. So when you press the enter key, that is considered one line. So that is how stream reader read line knows that there is a line there, because it is looking for the new line character. So the new line character in programming is denoted by carriage return and line feed, like this, right? So the \r\n means pressing the enter key in Windows machine. Alright, so why you put backslash? Backslash is to tell the operating system that this is a special character called carriage return and line feed. \r means return. In the olden days, we use the old typewriter where you need to push the platen, which they call it the platen, the thing that rotates on top. You need to push it to the left. So that's the meaning of carriage return. And then we are still retaining the convention by using the character R here, right? So this is a little bit of extra tidbits for your information. So this is the meaning of read line, new line character. So when it finds the character \r\n, then stream reader knows that it has found a line. So it will read the line and save it to the string which you declared here. So now this string here, line, has got the characters that was sent by the client. So the next thing you want to do is to look for the character that is going to be sent. So we are going to continue with the coding in the next lesson. See you then. Hello and welcome back. In the previous lesson, we already did part of the code for your simple network program. Now we are going to continue. So in the last lesson, here is where we stopped, where we read a line from the stream and save it to this variable called line. So the next thing we want to do is we need to look for any special symbols which is sent by the client. So you have to plan first what special symbol you want to use. So a special symbol, it can be any character like M or S or T, so that it has a special meaning for the server. For example, if you wanted the server to show a message box when you receive the character M, so you must look for the character M. So how do we look for the character M from the string? We can use a function line.lastIndexOf. So when you type line and you put a dot there, you will find that there are a few methods which exist for a string, for the string class. Remember that line is actually a string, so these are the possible methods that exist for strings. And the one that we want is lastIndexOf. lastIndexOf. lastIndexOf will search for a character in the string. So just select this now, and then what is the character that you want to search for? So we have already agreed that we are going to use the character M. So all we need to do is now type the character M, and then here lastIndexOf. So we need to test whether the last index is bigger than 0. If the character M exists, then this line.lastIndexOf will return a value which is bigger than 0. So we need to test for that. So to test for that, we need to test whether whatever is being returned is bigger than or equal to 0. So if whatever is returned is bigger than or equal to 0, that means the character M exists in the string. So we just put the if statement in front like this and put brackets surrounding it. So this in programming is called an if statement. An if statement will test the statement inside here whether or not whatever is expressed here is true or false. So in this case here, the line.lastIndexOf method will return a value, whether it's 0 or less than 0. If it returns anything less than 0, it means that the character is not found. If the character is found, it will return 0 or more. Then it means that the character is found. So this is what if is testing for. It's testing whether or not you manage to find the character M in this string. So if you manage to find it, then you want to do something. So what is it that you want to do? You want to pop up a message box. So straight away you type message box dot and then select show. And what message do you want to show? Just say hello. That's all. Like this. So this one reads like a simple English sentence. It means if the last index of line for the character M is equal to 0, show the message box. Show hello string. Alright, so that's what it means. So after you have done this, you need to close everything. So you need to close the stream reader, you also need to close the network stream, close it in the reverse order in which you open it. So here stream reader was the last one being opened, so you need to close it first. Then the second one open was the network stream, so close that next. And then next one will be socket in reverse order. So socket for client dot close. And finally, to close the whole program, we use a special function called system dot, and then from the dot there is environment. So just type E, environment, this is the one you want, and then dot exit, like that. So the exit code, you can put anything you want, right? You can put 0 for example, so you can just type 0 like this, semicolon. Alright, so this is how you close the program by calling the exit function or exit method. So okay, so now our program is there and is ready to run. So we can now click on start to let it build this program and then run it. But it will be invisible. You won't be able to see it. But you can go to your command prompt and test it. If you have closed your command prompt, just open it again. Click on this one here, the Windows icon, and then search for CMD, and then click on command prompt like this. And then from here, type netstat space dash DAN and hit enter, and look for 4444 to see whether or not it is listening. There you go. 4444 is now listening at the local IP address. 0000 means any IP address. That means if it has got a 2 network interface card, 2 adapters, both of it will be bound to this port. So now we can connect to port 444 by using telnet. So open another separate command prompt, CMD, and then now we are going to connect to ourselves at port 4444. So we're going to use the telnet program. So just type telnet and then specify your IP address for this machine. So you can type localhost, or localhost saves you the trouble of typing out the numbers. Localhost 4444. Alright, press M and hit enter. There you go. Hello message box shows up. When you click OK, you will disconnect. You will disconnect, and here you see your program has closed. Right? So all it does is it opens a port at 4444 and then creates a socket out of 4444, and then it waits for you to type something. Once the client is connected, it will connect, create a socket, and create a stream for the socket, and read the stream. And then you will read a line out of the stream once the user press enter after pressing the M character, and then it will store it in the line string, and then here it will search for the character M, like that. So once if it finds the character M, then it will show message box. Alright, okay, let's try it again one more time. Run, and then open a command prompt, CMD, and then telnet. This time we type 127.0.0.1 spacebar 4444, hit enter, and then press M. You won't be able to see the M there, just hit enter, and again the message box pops up. Okay, so this is the second way to connect using numerical IP address. Okay, I'll show you another way. So now the program is quit. Run the server again, and then come back here, telnet, but this time we are going to telnet to a different IP address. So to find out what available IP address there are, open another command prompt and type the netstat command again to see what other available IP addresses for these machines. So you can type netstat space dash DAN, and then you can find that there are multiple IP addresses for this machine. 127.0.0.1 is one of it. The other one you can use is 192.168.0.114. So just telnet here 192.168.0.114, 192.168.0.114 space 4444. Now this IP address is given by my local router. When I connected to my access point, I automatically got this address. So now I hit enter and I press M again and I hit enter and again it pops up. So again it works. So you can see one machine can have multiple IP addresses and all of it can be used for networking. So in this case, that happens because of this parameter here, any. That means it binds to all the existing network interfaces for the machine. So okay, I think that should be it. Right, you can actually play with this to add more different messages that you want to show. So if you type M, it shows a message hello. If you wanted to show a different string, then you can put another line, copy this line, put below it, and change the character here for it to show a different string. So now I leave you with an exercise for you to try. Modify this program to show a different message when a different character is being sent. Alright, maybe goodbye. When the client sends the character G, you want to show goodbye. So try that as an exercise, and I'll see you in the next lesson. Thanks for watching. Hello and welcome to the practical walkthrough. In this lesson, we are going to build this multi-command ret which we have designed in the previous lesson. So let's get started. Open up your Visual Studio 2019 and then click on Create a New Project. On top here, select C#, Windows, Desktop, and then scroll down and look for Windows Forms App.NET Framework. Select it and then click on Next. In here, give it a name, call it 02 multi-ret. And then here, click on the three dots and navigate to the folder called Ret Projects over here and select this folder. Click on the button Select Folder. Make sure your settings are as follows and then click on the Create button. We are going to make this an invisible ret. So the first thing we need to do is to set the opacity of the form to 0. First, select on the form and then come to the Properties windows, scroll down until you see opacity and then set the opacity to 0% and hit enter. Next, we need to create a form shown event handler. So click on this button here with the lightning icon which shows event and then select the shown event and double click on it to open the code view. Visual Studio has created a method called form1shown and inserted it here for you. So you can go and download this file from the resource section. So we are going to copy the form1 class, copy the class, everything that's inside the namespace until here, from here to here. So right click and copy, and then when you come back here, you select all this until here, delete, and then paste the copied code into here. Now we need to fix the imports. So come back here, go to the top, select all the imports from here, copy and then paste it in here, delete this and paste all the imports. That's it. So now you have got your new code already done. I'm going to explain how it works. So what we have done here is almost the same as the previous one. We have this .hide, which purpose is to hide the red from the taskbar and the task manager. And then we create a listener at this port 4444 using any IP address available that is bound to this machine. And then we save the listener to an object called TCP listener, which we declared here. So we declared it here because we want these objects to be global scope, meaning that it can be viewed from any method inside this class. Previously, our TCP listener was inside form1 shown function, but now we moved it outside so that it can be viewed from other functions. And then over here, we will start the listener using the start method. And now we have a new user-defined method called runServer. runServer is declared over here. Notice that the signature is private void. Private because we only want this method to be visible from within this class and not from externally. Void because there's nothing that is being returned by this function. So inside this runServer, we put our usual code for creating a socket. So we call TCP listener.accept socket and return the socket to this object which we declared up here, just like in the previous lesson. The only difference is the socket is declared now outside of the function form shown. It is declared up here, but it is initialized inside runServer. Next is we will create a network stream and then pass the socket for client as a parameter for the network stream and then return it to the network stream object which we declared up here. And then we create a stream reader and then assign it to this object called stream reader, which we also declared up here. Then we come to a new part which you have not seen before, a try-catch block. A try-catch block is to handle events to handle exceptions or errors which is thrown by the program, so that the program will not crash. So the purpose of putting a try-catch is to make sure that the program can exit gracefully rather than crashing suddenly and then giving a bad experience. So whatever you want to try, you put it in the block here, and if anything bad should happen, it will be caught in this second block called the catch block. And once the catch block catches all the errors that can happen in the try block, you can then deal with it down here. And the parameter that the catch will receive is called the exception object. The exception object will contain all the details about any kind of error that can happen, any kind of exception. Exceptions are errors. So, and you can deal with the error in any way you want, but in this case we are not going to make use of this object, but we want to use this catch method to shut down the program. So let's see how it works. Inside the try here, we declare a new string called line. The line is used to store the message which the client sends to the server. And then inside here, we have the while loop. So this is how we create a message loop, as you have seen in our earlier design. We put an infinite loop by passing the true parameter to the while loop. So that makes it run perpetually. And then the loop will only quit when we reach this line. If the message that is received from the client is Q, then we create an exception which should be caught by the catch block here. So once you throw a new exception, it will be caught here, and then you will close everything. Stream reader, network stream, socket, client close, and then you exit this program gracefully. And this also will happen, an exception will also happen if the telnet client suddenly disconnects. So we use this catch block in an ingenious way for two reasons. First reason is we want to quit when the user sends the Q message. So when the user sends Q message, we create an exception artificially so that it will be caught here. The second reason is if the client suddenly disconnects, could be a network outage or whatever. If the client suddenly disconnects, it will also create an exception which should be caught here, and then it will also gracefully close. And then while this loop is perpetually running, the message it can receive is M, B, and Q. M is to display a hello world. So if the client were to send the message M, then you will show a message box hello world on the server side. If the client were to send the message B, then you will beep. So you use this function called console.beep. The first parameter of beep is the frequency. As you can see, when I hover my cursor over the function, you will be able to see the parameter for beep. The first parameter is the frequency. Frequency is the pitch. How high or how low is the tone that you want to generate. And the second parameter is the duration, which is how long do you want it to play. So the duration is in milliseconds. So in here, first parameter, I put 500 to indicate that I want to play this at a frequency of 500, which is in the intermediate range, not too high, not too low. And the second parameter, I use 2000 milliseconds, which means I want to play this beeping sound for 2000 milliseconds, which is actually 2 seconds. So when this thing runs, it will run perpetually and continue to receive the M and B message and show the whatever message that you specify here, hello world. And if you receive B, it will play a beeping sound, and if you receive Q, it will quit. So this is how the program works. So in the next video, we are going to run this, we are going to build this and run it. So thank you for watching. I'll see you in the next video. Hello and welcome back. In the previous video, we have already created our source code for our multi-rack project. So in this video, we are going to build it and test it out. So let's click on Start Now to build the project. As you can see, build has started. And I believe it is running. Build succeeded, as you can see on the bottom left corner. So now we can open a command prompt. Alright, now it is running. So let's open a command prompt. If you are not sure whether or not it is running, you can always check using the netstat command. Hit enter, and then scroll and look for the port 4444. Over here you can see it. So this confirms that the server, the rack, is up, running, and is listening for connections. Now we can connect to it. Let me clear the screen first by typing CLS. Then we will telnet 127.0.0.1.4444, or you can telnet to your IP address which is available for this machine, which you can also check using netstat, or you can also telnet to localhost if you like, or you can even transfer the binary to a separate machine and telnet to that machine if you prefer. Okay, let's hit enter now. Alright, so it should have been connected. So let us test our first command, which is M. First command is M. So we are going to type M and see what happens. Press M and hit enter. And you can see the message box pops up. Hello world. That means this part is working. Message box is shown. Second, we want to play a beep sound. So you're supposed to type B. So let us now type B and press enter, and I remind you that it will not show whatever you type when you hit. And you just heard that, right? The beeping sound. Let me try that again. I press B. Yes, so that is the beeping sound. So you can change the frequency and the duration if you prefer by going here and then just change the parameter for the beep. If you put a higher value, then the frequency, the pitch will be higher. If you put a lower value than 500, then the pitch will be lower, the tone will be lower. And if you want it to play for longer, you can increase the value here, or shorter, you can decrease the value here accordingly. So let us now try one more time the M command. I type M and it shows the hello world again. And if I type B, it beeps. So this confirms that our red server is running in a loop. So this is what we need. We need the server to be always running in a loop and waiting for commands. Now if we want to quit, we just have to press Q. So let's press Q and hit enter. And you can see immediately that the red has terminated up here. You can see it's no more running there. Exception thrown, system exception, exited with code 0. Alright, so when we press Q, it will artificially create an artificial exception. And when you do that, it will be caught by this catch block. That is why you see this message here, exception thrown, system exception. So once the catch block catches this exception, it will then gracefully close everything. The stream reader will be closed, and network stream and so on. Everything will be closed and it exits gracefully. And you can continue, you can run it again if you want. So another way to run it is to run the binary file itself. Now to get the binary file, you can head over to your folder where this project was created. So we can go to the folder now, go to your C drive, and then go to the red folder, (02) multi-red, and then inside here open the folder and look for bin, which stands for binary. And then you have two subfolders, debug and release. Debug is to store the binary for debugging version. Presently we are on debugging, so it will generate an exe and put it in here, multi-red. Later, when we change this to release, when we click this and change to release, and then it will put it in the release folder, which is this one. So currently, if you open debug, you should see a exe there, and you can double click on this to run it. And then now you come back to your telnet and repeat the same command. Okay, let it wait for connection. Now we press M, hit enter, and again it works. And then we press B, hit enter, and it works. And you press Q, hit enter, and it should have quitted. Okay, And so you can confirm that it has quit by opening a command prompt and then type netstat, hit enter, and look for 4444. Okay, try one more time. It hasn't quit. Alright, now it has quit. So now let's repeat the command netstat again. You can repeat it here, the command netstat, and check, make sure 4444 is no more there. Yes, it is closed. So our program works. So these are two ways you can test your program. You can either test it by clicking the start button, or you can go directly to the debug folder, which contains the exe file, and double click to run it directly. So that's all for this video. We have now got a basic template on which we can build a simple but workable rat. So where do you think you should put new commands that you want to implement? Yes, you should put it in a while loop. This is the message loop, and you should put whatever new command that you want to implement inside here. Just copy this line, create a new line, and add whatever command below it that you want to execute. So we'll be doing that in the future coming lessons, how to add more commands. And not only that, we will also improve on the design of this rat. So that's all for this video. Thank you for watching. Hello and welcome back. This is a new lesson where we look at multitasking threads. Multitasking threads are useful for creating a multi-threaded rat. Why do we need to have multitasking threads? Let's take a look at our previous design for our rat. On the left we have our client, and in the center is our server rat. The server rat has got a message loop, which is actually a while loop which runs perpetually. So when the client sends any messages, it will send it to the server rat, which will then receive it and process it. The problem with this design is that while the server is processing the first message, if the client were to send a second message, it will be held in the queue. It will not be processed immediately. So the second message will need to wait for the first message to complete. That means if the first message is displaying a message box, the message box will have to be closed by the user before the server can process the second message. And if you have multiple messages which can be received by the server, they all need to be held in the queue to wait for their turn. So that is a distinct disadvantage for the server. It would be ideal if we can have a server that can process messages concurrently at the same time without having to wait for the first one to complete. So that concept is known as threads. We can use threads in order to accomplish that design goal. So in this old design, you notice that I've put a double-headed arrow here, which means block. So this is called blocking design. Blocking design is where a process runs sequentially from top to down, and it cannot proceed to the next one unless the first one has completed. So if you take a look at the code for the earlier design, you will see that this is where the blocking happens. So in a while loop, if the client were to send a message M, then the server will call the message box to show the hello world. And whilst it is showing the hello world, if the Telnet client were to send another message, let's say B, to beep a sound, it will not happen. It has to wait for this instruction to complete. The message box must complete, must shut down, must close before the server can go ahead with the second message B. So this is called blocking mode. So this is a major disadvantage for servers. So let's see how we can improve on that. Now this is another new design, multitasking threads RET. On the left you will see the client as usual, and the client can send messages M for showing message box, B for beeping, and Q for quit. Now we are introducing a new technology here, which is called threads. So threads are mini programs. You can view them as mini or small programs running within the main program. The main program is called a process, and inside a process you can have many threads. Each thread can do one task, and they do not block each other. They can run concurrently. So that is what we mean by non-blocking. So if the Telnet client were to send the message M, the server can spawn a new thread to handle the message M, to show the message box. And whilst the message box is still being shown and has not yet been closed, and if the client were to send a second message M, the server can spawn a new thread to show a second message box, even though the first message box is still on screen. And the client can keep on sending as many messages M as he wants, and he can spawn as many threads as he needs to show all the message box at the same time. And the client can also send B, a beep command, in order to sound a beep, even though the message box is still being shown. So this is the beauty of having threads, which can solve our design problem. So let us take a look at the practical example of this problem in the old design. So let's go back to our earlier design, which is the blocking mode design. So let us run this now and see the problem for ourselves. So now the server is running. We will open a command prompt and telnet to our server. So now it is connected. Let us open the message box by pressing M and hitting enter. Now the message box is showing. Let me try to send another message M. I'll click in here and I press M and I press enter, but nothing happens. The first message box is still there. Second message box is not showing. Now let me try to send a message B to sound a beep. So I click in here and I press B and I hit enter, and no sound could be heard. That means this program is blocking at the message box. So it is blocking over here. That's why the second message box was not shown, and the beep also was not shown. So see what happens when I dismiss the first message box. When I dismiss the first message box by clicking OK, the second message box shows. Now let me close this again, click this and see what happens. And now the beep sounds. So you can see all the messages that are received by the server is held in a queue waiting for its turn. So this is a distinct disadvantage of a blocking server. We call this a blocking server because it is blocking each other. Each message, each task is blocking each other. So now that we know how to solve this using threads, we will proceed in our next lesson to design this multitasking thread RET. So thank you for watching. I'll see you in the next lesson. Hello and welcome back. In our previous lesson, we have already designed the new red, which is based on multitasking threads as shown here. In this practical walkthrough, we are going to create this in our Visual Studio. So let's take a look. Go and open your Visual Studio 2019 and then click on Create New Project. Make sure your options up here are C#, Windows, Desktop, and then select Windows Form App.NET Framework and click on Next. In the project name here, we'll call it 03-multithread. And then here, click on the three dots and navigate to your red projects folder and select it. And then click on Create. The first thing we are going to do is to set the opacity of the form to 0. So click on the form, come down here, make sure you click on the properties here, and then scroll down to opacity, which is here. You can either list it based off of alphabetical order or by categories, but make sure you click on properties first. And then for the opacity, just set it to 0% and hit enter. Next, we'll insert a form shown event handler. So click on the lightning icon and scroll down to look for the shown event. Select it and double click, and it should be inserted for you over here. In future, if you wanted to look for this source code, you can come down to the form designer, click on the form, and then click on the first one here, the constructor, this one. So when you click on this, you'll be able to see all this code listing here if you ever need to make any changes. So now over here, we are going to copy our source code from this file, which you can download from this resource section. So let us copy all the includes from here first. Copy, come to the code, select and delete all this, and then paste the copied code in here. Next, we'll delete all the main class here and replace it with our own new code, which is from here, the public class. So select all this all the way to here. Select all this. Inside the namespace, select the public class form1. So select that, copy, and paste it in here. There you go. Then click on Save. So let me explain the new things. So what is new here? We still have the form1 shown event handler and the hide function, display listener start, and we also still have the run server. However, there is something new in the run server. In the run server, we have our while loop as before, but this time, whenever the server receives the message, whether it's M or B or Q, it will create a new thread, and then it will assign it to this thread object, and then it will start the thread. So this thread object here comes from using the system.threading library. It is used for creating multiple multitasking threads that can run concurrently. So in order to use threads, we have to make a declaration here. We have to create two thread objects, one for the message and one for the beep. If you have more than one command messages, then you put it all in one line here. So use a separate thread for each command so that the server commands can run concurrently instead of blocking. So currently over here we have two commands, so that's why we create two threads, th message and th beep. Th is a abbreviation for thread. So over here we use the constructor for thread, use the new keyword and call the constructor for thread to pass a new thread start object and then assign it to thread message once the thread has been created. So the thread object, the thread constructor accepts a thread start object. So that is why we need to call the thread start constructor inside the parameter. So when you use the new keyword here, it means you are creating another object. So this object is created on the fly. That's why we don't have to specify another different separate object just to store this. We just want to create on the fly and then directly assign it to the parameter for the thread constructor. So the thread start object accepts the task that is supposed to run for this thread. So here you pass this function message command, and message command is over here. So over here and here you will put your message box in a separate function like this, and your beep command in a separate function like this. So we call it message command and beep command, and inside it you can see our familiar message box show and the console beep function. So why we do it this way? So that we can pass this function to the thread start object when we create the thread start object. So after that we get a new thread being created which has got this thread start task that is supposed to perform, and then we store it in the thread th message object. After that we need to start the thread, so we call the start method that is found inside the thread. The same thing happens for message B, but this time we pass it a different task, a beep command task, and then we assign the new thread to the beep thread and then call it start method as well. So in this way, when the server is running, this loop will not block. It will keep on looping. It will not stop or pause to wait for any lines. It will just run. When it comes to this line, if the message is M, it comes to this line, spawn a new thread and continue to move to the next line. So you can run concurrently any number of threads at your discretion. So, and then last one is your quit message. The quit message does not need a thread. The quit message is the same as before. When you receive queue message, you just create an artificial exception so that you'll be caught by the catch block, and the catch block will then close everything and exit. Once the process exits, all the threads which are children of the process will also be killed instantly. So that is how it works. So that's the only new thing here. So in future, if you wanted to add more commands to this server, all you need to do is just copy this and then paste it below, and then put in your new thread task that you want it to perform. and then you have to define your task over here. And of course you also have to define, you have to declare your new thread objects up here as well. So that's all for the explanation for how to implement our multitasking thread red. In the next video, we are going to compile and build it, run it, and test it. Thank you for watching. Hello and welcome back. In our previous video, we have already created our multi-threaded red based on this design. So in this video practical, we are going to compile, build and test it. So just click on the start button here to start the build process. And now the build has started, as you can see. And now the red is running, and we can open a command prompt and test it out. So let's click here and look for a command prompt and open it, and let's connect to our red. At port 4444, hit enter. Alright, so it is connected. Let's give the M message. I'm going to press M for message and then hit enter. And straight away you see down here, the hello world message box is shown. Now I'm not going to close this. I'm going to leave it open and I'm going to press another M to see what happens. So I click inside here. I am going to send another M message to the server. Press M and hit enter, and now you look at the bottom, another hello world message has just popped up. So now we have two hello world. See that? Now I'm going to press B for beep and see whether it beeps. So I click in here again. This time I press B and I hit enter. There you go, it's working. Alright, now I'm going to open a third message box. Let's press M again, click in here and press M and hit enter. And now you see at the bottom, our third message box has just popped up. So now you have three message boxes open concurrently, three threads, and one beeping sound which has completed. Now we are going to sound the beep again, click in here and press B and hit enter. There you go. So all our threads are running concurrently. You can run as many, you can send as many messages as you like, and they will not block each other. So now I'm going to close everything. I'm going to press Q to send the quick message. Click in here first, press Q and hit enter. And you see, all the message boxes has disappeared and the server has shut down. Alright, so it works like a charm. So this is the basic concept of multitasking threads which you can implement in your server. So it's a good template that you can use. So every time, anytime in future, if you wanted to implement new features for your red, all you need to do is to create new threads, declare new threads up here, and then create another if block for the new thread and define the task that you want the thread to perform and put your task in here. That is all, as simple as that. Alright, so that's all for this video. Thank you for watching. Hello and welcome back. In this new section, we are going to take a look at multi-commands. We are going to build a simple red that can accept multiple commands. So this is a design of a simple multi-command RET. On the left is your client, which in our case we are going to use Telnet. And Telnet is going to connect to our server, and this is the server we are going to build. And this server is a RET, a remote access tool, which has the ability to accept multiple commands. So the client can send 3 commands, either M, which means message, in which case the server is going to show a message box, or the command B, which stands for beep, in which case the server is going to sound a beeping sound. And the third command is a Q command, which stands for quit, in which case the server will just exit the program. So in order to make this work, we have to ensure that there is a message loop running in the server. So the message loop will keep on looping and looping and looping, provided it has not received the quit message. Once it receives the quit message, it will break out of the loop and quit the program and shut down the server. But if it does not receive the quit command, it will continue to loop. So once it is continuing to loop, it can accept any of the commands M or B. So each time it accepts an M command, it's going to display a message box. Each time it accepts a B command, it's going to sound a beep. So this is a simple template which will be developing further for a more advanced RET later on in the course. So for now, we are going to do this project so that you get an idea of how to create a message loop that can continue to loop, to continue to accept commands. So this is our design, and in the next video we are going to go ahead with building this new RET. Thank you for watching. I'll see you in the next video.